very much, Dr. Neha, for brief explanation, and so much. It proves that it's a mathematics conference because you already conclude that it's exponential and something series is going on for the citation matter. Thank you, Professor Singh, and thank you, Professor Jadov. Thank you, Professor Dem, so for inviting me for this conference and allowing me for my presentation. However, what I would like to present today that, of course, a model I will present, and I will give some brief idea that what the direction of the inventory and supply chain management can relate now in a world. But what's the thing I want to say that little bit different from our basic model. That means, suppose whenever we are trying to go for any inventory modeling or go for any supply chain modeling, then we are assuming some buyer, supplier, some specific one model or two models are there, and then we are trying to cooperate with some rate of change of inventory differential equation. We are trying to relocate with the differential equation. Sometimes with the difference equation, sometimes with the differential equation. That I'm not showing today. So what I want to do something regarding mathematics, a little bit hardcore mathematics, but that's why it may look like something difficult thing. So let me start. So I will try to cooperate with each one that such that you can understand properly. Hope so. Means I will try my best to do that. So is it visible?
Yes, sir. Yes, yes.
Okay, so let me start now.
Fine, sir.
Let me start now. So first of all, I will start with something smart products and the concept of the smart production. And then what exactly we want to do, that I will tell you through a research paper that we published earlier. So the content is that introduction of smart products and smart production system. And with this, what we will explain properly, what is that, first of all, that the what is that smart products, what is the smart production, and what is its feature and what its necessity, and then within a mathematical model, how do we do with something operative, that means with the specifically inventory control without consideration of the differential equation, that exactly what we do generally initially, right? Like that dq equal to p minus d, the production minus demand. The rate of change of inventory is production minus demand. Or suppose if we go for the EOQ model, then we are going with the rate of change of inventory, that dq equal to minus d. That we are not going to consider. What we would like to consider there, that the consideration is like uh, how many product entering to the machine and how much the machine will produce. So this calculation and how the labor, that the human labor is introduced within it, that means how many skilled labor, how many unskilled labor, how many semi-skilled labor are involved, and what type of equation can be represented through that with some hardcore mathematics. So that's why I said that like so much mathematical expressions are there. So let me explain one by one. So first of all, we start with that. What does it mean by the smart products? So smart products is nothing but that it must be a complex product. Like I'm just giving an example. When we have some Pentium 1, so it's a big size computer with very less amount of capacity. Capability is very less. Now day by day, Pentium 1 to Pentium 2, then Pentium 3, Pentium 4. What does it mean? It means that the complexity increases. It means complexity means that capability increases. Suppose if you have a big size camera, it doesn't think anything big thing. But if you have a very small camera can do several things, then it has something good effect. That's the concept of the smart products. Like earlier, we will use that mobile phones for just call and camera for taking phone. Now just combine together. That mobile phone contains camera with some more powerful things. So that becomes the smart products. So that's why we call it that smartphones. That means smart technology must be there. So specifically in a short sentence that I make it bold, the smart product attains a smart technology, whatever it is, bulb, or if you go for a Tesla car. So it means that it must contain something smart technology within that. And what is the benefit of it? The benefit of the smart technology is that whenever it introduces within the smart products, so that products will be more flexible for our case. So suppose I'm just giving the example of the bulb, like earlier we have the bulb with that 60 watts, so in an hour, so that the total 60 what it will take by time. Now the demand is for light only, not the amount of energy. So what is the task? Reduce the amount of energy consumption, and the light should be more. So that is the main task. So that is the new technologies are doing with the smart uh, application, that the wattage will be reduced, that 60 watt is reduced to 10 watt, 11 watt, 25 watts, something like this, and the light will be more than the 60-watt bulb. So people are using that bulb, that is the LED light and something else. So this is the concept. So just like this type of smart products are preparing. So these are the specific characteristic type. Now let me explain these things. First one is that adaptive nature. What does it mean, this adaptive nature? Now think about that. I have a laptop which has capacity of 2 GB. But what I'm thinking when I'm taking class, hello? Okay. So when I'm taking class, I'm thinking that the 2 GB RAM is not sufficient. So that's why I just send an mail or contact to the company that okay, I need 10 GB RAM. Now if we go for 10 GB RAM, so then I can buy this thing. So this is the adaptive nature. So we contact the company, and from the customer feedback they want that the laptop should be with the 10 GB. Now personalization. What is that personalization? When the 10 GB laptop, that means the RAM capacity is 10 GB, it comes to me. So then I said, no, I cannot buy this one. Why? The problem is that with they make this 10 GB RAM capacity, but the price of the laptop become near about 3 times or 4 times. So this doesn't meet our satisfaction. So that combination of adaptive nature and personalization means that whatever I will say and whatever they will provide, it should meet our satisfaction level. If we get that satisfaction level, that means the product will be sold. Otherwise, even though this is smart product, it is not sold. Next point is that the intelligence. This is the intelligence is the capability of the product adjust in the situation. Suppose whatever I said that I judge that I need the 10 GB RAM capacity. So it can be done like only with the 4 GB RAM with the more powerful hard disks. So if they understand these things, so they make a combination of 4 GB RAM with a more powerful capacity of hard disks that may solve my issue instead of this 10 GB RAM. So that is the intelligence function, the capability within the R&D sector from the company. And next, for the connectedness. Connectedness is that one. You just not in Korea, I cannot say, but in India, several students are there. They always do these things whenever they are doing their research task. What they are doing, they just save the task in their computer. And suppose you just save everything and then shut down the computer tomorrow morning. You just, when you get up, when you open the computer, you check that the computer screen is blue, it is not connected anything, computer totally gone, somehow hard disk crash. So whatever your task is totally gone. So what is the important task is that, so you should do this through the cloud. So if you save this data through the cloud, through your mail or through anywhere, if you do this thing, if your computer gone or it will not gone, you do not have to bother. You can just take this data from the cloud, problem solved. Like that, suppose I'm working from home, I'm working from university, I'm working from my lab. So different places I'm working. But it is not possible to carry my laptop, my computer everywhere, wherever I'm going. So wherever I'm going, I can just connect with my cloud with my ID password, and immediately whatever be the data I can access from there. That is the benefit of the cloud server. That is the smart products thing. Through cloud, you can do it immediately. So even though computer crash, it doesn't matter. You do not have to worry about this. So for the students who are considering this research for this type of smart product, they do not consider this type of thing. So just okay, save the file, working on the smart production, working on smart products, even though their data is saved in the local computer, is not in the cloud. Next matter is the sensor or sensing level. That is the information sharing of the using the AI. So this is a little bit new concept regarding the artificial intelligence. Everywhere we are trying to relocate or locate through the AI technique. So this is not applicable for all products, whatever existing we have right now. But many smart products are covering with these AI products. Next, for this automation, within this automation, there are two type of things. One is automation, and the second one is the automation. What is this automation? Automation means that the whole system will work with the automatic system. That means one human being is there to control the whole automatic system. And what is this automation? Automation is that if there is something defective products or imperfect something, so uh, that the system will inspect automatically by system will automatically inspect by itself. So there is that one no will be inserted within the automation. So there is auto auto and then there is no word is added to ensure that the inspection is done by the computer total. And this automation is the main area to activate that human machine interaction. What is that human machine interaction? That the area is like, suppose in a word file, when we are pressing, suppose just like, suppose you write like, like, you press L, then how do you assure that this will show you in the keyboard whenever you are pressing in keyboard L? How do you sure that in the word file it will show you that symbol L? So that is the human machine interaction area, that whatever you want to do with machine will follow your instruction properly. Next one is the resilience. Resilience is the capability of the situation for service. Whatever you need the service. Suppose I need that my computer is gone. So where exactly I should go and who can solve my issue? This is a big problem for service. If the service problems can be solved, then huge amount of smart products can be sold immediately. So there are this service is more important issue for smart products. Next formation of the reconfiguration. Reconfiguration is nothing but that whenever you have the problems, some problems coming for any smart products or smart gadgets, so these type of problems you should solve properly within the proper time or within the less amount of time with less amount of cost. So these are the characteristics of the smart products. Now I'm just giving an example of comparative study with the traditional and the smart products. So whenever you are going for traditional products, you have two options: either go with something with warranty or without warranty. Now, if you go for smart products, generally it is with warranty. Not always, but 99% case it is go with warranty point. And some cases it has some extended warranty also. Now, don't ask me that, okay, sir, I have a smartphone, then why it doesn't have the warranty? It's talking about the smart products for the larger products, something like this, the big companies, big machines. So these type of things are there. Even though if you go for the when you are buying the mobile phone, so there is some warranty, maybe some very less days or month, but it has something offered from the company. So the main issue is that there is some without warranty for traditional products also, and then whatever that without warranty products, so that all expenses are borne by the customers. And important point is that whenever the traditional product is there, that is not eco-friendly and not energy efficient. Now please go for the refrigerator. If you go for buying a refrigerator, the smart refrigerator is there. If you go to shop, you please check, there is the indication that the energy in a year, how much energy it will consume. So that is the concept for the smart products, not the old refrigerator. If you go there, there is nothing mentioned, the company brand is there, okay, this brand it is good, some of your friends said, okay, this is good, so okay, you can buy. But nowadays you can judge by yourself, okay, in a year this amount of energy it will take, this amount of cost it will come, because of, you know, that that means the energy price, that means electricity, how much price per unit, so this amount of extra money you have to pay. So these type of things are the benefits for the smart products. Now, in a sentence, if you ask for the what does it mean by the smart production system, so it is like this: self-organizing autonomous machine system with a cyber physical system. So whenever the cyber physical system is there, so definitely this part is covering by cloud server and storage data in the cloud, not in the local machine. So what is the feature for the smart productions? One is the distributed intelligence. This is the main matter of the this one is the single line production, here will be the multi-line, or say multi machines, or say single machines. So different combinations of smart products are produced. So the important task is that the conveyor loop or closed loop conveyor belt is forming within them, or you can say just buffer. So that the inventory system, that we know that the buffer inventory. So here is the conveyor belt is the will be used for the same purpose. but this is like automated and connected with all the software. So that's why when one skilled labor will operate, so that will operate automatically. So this is the some feature for the smart production system, but this is just like in machines and is a assembly line we are working. So suppose one is the machine one, then go for machine two, then go for machine three, and then go for machine, and then the final product we will get. Now suppose forget about this one. Now if you have a pen, just a pen, this is not a smart product anything, but the pen is a combination of plastic and metal. So you cannot make this type of things that product machine one to machine two, machine two to machine three. So there will be some plastic part is one side and metal part will be one side. So and then there will be some assembling combination. So that time you should get something m cross n dimension. This is just I'm giving example for 1 cross n. Assembly line is a single production system. And each part, whenever these things are going on, there is something you please check that automated inspections are there. What is this automated inspection? That everything is done by the machine, and there is system is set. So suppose 95% perfect, it means that the product is totally perfect. So this rest 5% is ignored. So there is the problem for the smart production. What is the problem? And now come for the benefit and the problem. Benefit is that if you consider 95% product is assured, so then uh, all the product, whatever it is produced, you can assure the product are perfect. But 94.99%, this is almost accurate, but the machine or the computer is indicating that is a defective product. So these are the problem. Now if you said that the human being make some inspection error, so that makes a big trouble. So you have to decide the system should be totally automated, means fully automated, or partially automated. Which part human can make mistake more, you can set as automated machines. So and which part you think that human can do better, so that part you can consider by the human being. So this type of combination is going on also totally automated going on, and traditional things are continuously changing to the smart way. So now coming for the mathematics, whenever we are going for making some modeling, where is the changes? So I'm just giving 2 or 3 examples, then you can understand easily. When we are just making some supply chain model, we are writing the setup cost. What is the setup cost? Is constant setup cost we are considering S, or just suppose considering A, whatever be the cost. If you are going for the single stage multi machines with the smart production also, you just try to moderate with SI, nothing change, big deal with this, because these all are constant cost we are taking, and I equal to 1 to n. Why? Because there are n setup. I'm just showing once more, machine 1 to machine 2 until machine n. Each machine's setup cost is not possible is the same. So that's why we are taking summation of I equal to 1 to n SI. Similarly, is a big size machine and the smart machines are there. That's why we need the maintenance cost is too much important. So the same maintenance cost, if the last time we are considering for the traditional machine is just M, we can consider here I equal to 1 to n, because n machines are there, so mi. The important cost is that if we do not consider in the traditional model the energy cost, but for here huge amount of machines are there, so you must consider the energy cost, how much energy it will consume. So there will be that if you consider, then it is E, suppose E is the energy, here will be that EI. So that is the changes. So if you go for this one, there will be nothing big deal to make the smart production models. This is something we published paper, and then where the automation policy we published already these 2 papers, and another one with Dr. Vikas Kulide, that is the initial one that we published with the automation policy. Now let me explain about the assembly line with something m cross n dimension. M cross n dimension means that there are stage m stages and also that n machines. That is more complicated. And combination of the semi-finished product. Combination of semi-finished product means that suppose we are ordered some computer. Computer is not a single product. It's assembled with the spare parts like your hard disks, like your say keyboard, motherboard, and so many things, RAM. So many things are there. So just these are the 2 combinations that names are 2 types of names. One is that semi finished. Why? Because computer is the finished product. So in that sense, hard disk HDD is considered as the semi finished product. but hard disk itself a finished product because it can be sold again. So this double feature of this type of products are considered within this type of M cross N combination of smart production. And there is the combination of machine 112, it can go for uh, machine 21, and from machine 21 it can go again for machine 11. So different types of combinations are possible. So this is another feature of M cross N combination of the smart production. And everywhere wherever the inspections are considered, that all inspections are going with the automated inspection. The benefit is that automated is that this 90, if the R&D sector is assigned that the 95% interval is correct, or say 99% interval that inspection is correct, that means the computer will assign 99% correct, so then it is perfect. Otherwise it will be defective, because for assuming some laptop, that means when they are making some laptop, the accuracy level they need the almost 100%. So generally 95 to 99 is the accurate level for any spare parts for the electronic gadgets they are assuming. So for that's why this automated inspection is needed rather than the human inspection. Now if you go for this modeling part, what is the change for the multi-stage multi-machines? So that just what is, if we are please be concentrated that we are considering that constant. If you change the variable, so that will be change huge. So we are just considering the constant part. For summation, there is when there is only 1 cross n, so that is single summation. There we are taking just double summation, j equal to 1 to m and I equal to 1 to m. There is nothing big change. Similarly for maintenance, similarly for energy cost. And the biggest one is that what is for the traditional production system, whenever we are going with that, we check that the traditional production system, the production rate is always fixed. And smart production system or flexible production system or additive manufacturing, these are the biggest features with the variable production rate. For variable production rate, this important issue is that the production rate should vary within some limit. There should be some lower limit and there should be some upper limit. So that we just generally say that P min is the lower limit of production rate and P max is the that means the maximum limit of production rate. And within that, that production rate can vary. And this is generally we are considering for the production rate unit production cost expression, AP plus B by P plus C. So this A is the just tool die cost and B is the development cost, and this C is for generally for the raw material cost. Now think about that, if this B by P, whatever I said, if you think that this development cost depends on to something, so machine features, so that cost also we can take as a variable. So that is the content for the modeling side of smart production system. So that we just did some research on this area also. Just this is the some example, you can go for this reference for this one. And another one, just Professor Mista presented some days earlier. So this is with his paper that we invested some green technology matter. So through that one, that's main issue also for the smart production is that the control the emissions anyhow. So the emission should be controlled. So there you can use some investment. So that's the contribution from Professor Mista, that some investment function he contributed with the log functions. And this is the area that the human machine interactions that I said earlier, that if you press suppose G, that the button G in the keyboard, how do you assure that in the keypad it will print the word G or letter G? So there is something setting, there is something changes, whatever the instruction you will say, machine, how that will follow. That is the main content of the human machine interaction. In this area, I do not have a single research. I'm working on this area. I'm just entering through the automation, but still not yet done. So this is a big area of research for the smart production system. And this is the area where the society and technological development are the combination bridge. So this area is going on with the specification with the AI, that things are going on with the human machine interaction, that if we say something how the machine will work right now. Just suppose I'm just giving an example. Suppose if you ask your student to type something, what they will do, they will take the paper and start to type it. So there is some function in the Microsoft Word. So if you just dictate, it will automatically type. You do not have to type anything. It means that the conversation can change in wordings. So these type of things are that example of the human machine interaction. So that means whatever the research or whatever the other task, whatever we are doing, that becomes more smoothly. That if you know HMI, and if you know, that means improve HMI more, even though I didn't have any research about this area. Next, about the cloud database, that already I said that the smart production system means that everything will be saved in the cloud database, not the local computer. The benefit is that at a time, the R&D sector, the management, the people who is operating, everyone has can access the machine, and that what the things are going on. And that we have some paper we published in some last year, or not this year, sorry, in IJP, that that is considered that the end of life products with some RFID with the same cloud server consideration, that using cloud server we are using to save all data, such that the big boss means that who are the maintaining the companies, that the people in the R&D sector, they can have the data instantly. Suppose you, when you are the maintaining the machine, in a minute or in a hour, if the production rate is suppose 20, so it's a online or timeline data. That means they can count exactly, suppose 3 p.m. is this right now, so they can get that, okay, 3 p.m. so 10 products are produced, exactly 3.15 hours is there, and then they can check, okay, then 12 products are produced, just like that way. That real timeline data they can check immediately through that thing. And for this type of system, so there is the big benefit through this decision support system, and that decision support system is working through the AI and distributed intelligence with the help of this cloud server. And that also we have done something like skilled people means that there are three types that I said already, that whenever you are taking this human machine interactions, so there are three peoples are there. One is that the skilled labor, semi skilled labor, and unskilled labor. The most important case is that whenever we are taking this HMI is come into play, so then the effectiveness of skilled labor and semi-skilled labor is more efficient rather than the unskilled labor. And this is something formula we used, that how to decide that how many people, that means semi-skilled or skilled or unskilled is needed. So this is nothing but from the mathematics the weighted mean. So that formula we used here. And that I said that how to decide that one, that how many RFID tags using the products information getting one time investment, or say product based investment. So two different formula we used already on that paper. And now regarding about this benefit of the smart production in terms of sustainability, one is that economic benefit. Of course, the cost of information we are selling every time, whenever we have the information, operational cost is reducing, and quality of products automatically increasing, because if the product quality is not increasing, we cannot have this type of webinar through this. I'm staying in Korea and then presenting through here. It is not possible. We have to go there and then present that one. So this type of, you can say conformly that the quality of products and everything is increasing. So that's why we can do these things. Similarly, for the environmental benefits, the energy consumption automatically reducing, that I said through the bulb example, that the per unit energy consumption is reducing, waste of course reducing, and overproduction is also reducing. Whenever you have the information through the cloud that exactly this amount of demand is there, so automatically you don't have to produce so much product. That means amount of bull effect will be reduced continuously. And regarding your social benefits, automatically who are expert in the skilled area, that job will continuously going on, salary will increase. But there is a big risk, please be careful about this one. The risk of losing job is continuously increases for the unskilled labor, because so that's why what's the indication is going on, that means you please prepare yourself for the skilled labor direction, otherwise you may lose. That means like this type of thing you cannot do, okay, just get job and sleep. You cannot do that. If you do that, then job maybe lose someday. And next, I'm giving some example through that research paper which we published already. So I'm just going through that. There is the hardcore mathematics is there. So please try to understand. So there, this is a smart production system we want to explain. And within the smart production system, we are trying to show that cash flow, what the cash flow is going on. And of course, there are some carbon footprints there. That means the carbon emissions, of course, there. And smart productions are there also, and we are considering also the labors. That is the most important things are there. What the thing are these? What are the considering area when we extend this model? That one is that MRP, that material requirement planning, that I said during the production cost, that the last part C is the raw material cost. So that raw material is the most important thing, that every time we are taking raw material and then we sending the product. So that raw material, and we extended, this is called MRP, material requirement planning, that how to send how much amount of raw material we should send. This is the main area. And then we extended that one, extended MRP. Extended MRP is that we call that EMRP, and this is just like we make it the closed loop formation, which is includes the reverse logistics. That means that this one, whenever it is there, that it was just a supply chain, through that the forward flow is there, and someone did that forward, someone did that only reverse logistics, but there is no closed loop supply chain formation with that EMRP. What we have done, we are just making the loop formation, and to make this one, this becomes so much complicated. That's why I said that some hardcore mathematics is there to understand. So what is the main contribution to make MRP to EMRP? Is the contribution is that we are trying to make it closed loop supply chain. It's nothing but CLSC with something raw material information, that how much product is moving from one machine to another machine, not the inventory exactly overall the finished product inventory. We are trying to enter the raw material to make the final finish inventory. That's it. So that is the configuration that you can when you are there is the MRP system, that the material requirement planning, there is the production, then distribution, and then the consumption. What is our task? We are adding the reverse logistic here, the left side. So that reverse logistic and this MRP, we call it that EMRP. That's it. Now that is the mathematics. Wherever I am saying that we do not use this differential equation, we are trying to represent through the matrix representation. What is that matrix representation? Now just suppose this is the matrix. What is this A32 represent? This is the output data. So this implies a amount transfer from the input system 3 to the output system 2. So this first 3 indicates something input, and then second 2 indicates something output. But please be careful, these 2 output doesn't mean that it is the final finished product. It is the input for the next machine. So everywhere there is a block matrix. So using block matrix, we are trying to incorporate this whole inventory when this is unfinished. This is not finished product. So that is known as this combination of the economics and mathematics interdisciplinary research we have done. And this is that matrix representation is done by Leontiev in 1906, and this expired in 1999. So within that duration, he just invented this input output, that matrix representation for any type of that means using the block matrix, any type of product flow. So what is that EMRP system? Whatever we have done, that is just same system, that initially there are so many suppliers and it go for the raw material storage, then go for machine 1. Please be careful whenever say whatever we are doing here, the manufacturing center 1 to manufacturing center 2, and then finally assembling. So manufacturing center 1 to N it can go, and similarly manufacturing center 2 to N it can go. Similarly manufacturing center 1 to manufacturing center 2 it can go. So the point is that if you consider a specific product type, so this figure will definitely be changed, and automatically all modeling will be changed. So that type of raw material is there. Whenever we are considering any supply chain or any inventory equation that covering the inventory dq dt equal to P minus D, we do not bother that from where which machine is coming, which machine is producing. But in between, there are so much complicated equations are there. So that's why if you enter to this raw material calculation, this MRP calculation, it is so much complicated. And now whenever you have the final products, you are just going for inspection. This inspection is going through the automated inspection, that is through the machine, not by the human being. And then you have of course two options, the perfect, imperfect. And if it is perfect, go to the distribution channels. If it is imperfect, go for the recycling or the remanufacturing. And this part of this inspection, disposal, discounted sale, carbon emission, and return back to the MRP again, this part is added from our side. So that's why it's called that EMRP, not the MRP one. And wherever you are going with the whole system, everywhere the carbon emission is there. So that is counted. So that is the main task within the smart production, that the reduction of carbon emission must be there. So whenever you have the paper, so that the contribution is that whatever we have done, that Bogadas and Guruvastan 2013 they introduced this EMRP concept, but whatever they have done, that only they are considering the reverse logistic case. They do not consider the whole closed loop supply chain. So this we are considering, and that's why it becomes so much complicated. Of course, the carbon emission and discounted sale, other things we have considered, but this is the major contribution for the closed looping of the supply chain. This is the notation. So these are something like this. E types of components are there, and then going for the single type of product manufacturing through the automated inspection. If this is perfect product, go there from location 1 to 3 and until location R. Then from there, if it is okay, so then go for the consumption center. Consumption center means the retailing. They are taking the product consumed, and then after the consumed, there is something unused product. So that means this product we cannot use, so that part we can just throw it or recycle. That part we can use it again for the production system. So that's the basic assumption part. And the modeling is that we are considering here is that the first fundamental law of that manufacturing we are using here. So before that, let me tell you that about the matrix information. So this is H is the input matrix of products and material flow, and this G is the output matrix of products and material flow, and then P is the activity vector. That P is the, you can say, the block matrix. So just suppose one example for H34 means that, so it is the input from subsystem 3 and running to the subsystem 4. Same for G also. So this is the output from the subsystem 3 and running to the subsystem 4. So this way we are trying to develop all inventory, unfinished inventory, in terms of this block matrix. So if you just go through the similar way, so you can write that one is HP. H is the input matrix and it is the activity vector. Similarly, here is also that output matrix and the activity vector. So now here is the important theorems is coming, the fundamental law of manufacturing, the first fundamental law. The first fundamental law said that the rate of arrival and the rate of the throughput must be same if that the system is in equilibrium mode. Now suppose the left side is the arrival, that amount of raw material, and the right side is the product produced. So definitely input, that means HP, should be more, and right side the output should be less, because product producing more and input is come, that means raw materials is less, it is impossible. So but whenever we are calculating this one for the net production, please check, we are counting for that Z1 to Z4 is Y minus X. Y minus X is that output requirements minus input requirements. So it means that there is some chances for net production coming negative, because the raw material, if you are sending very small amount, automatically this amount of production will be reduced. This is the explanation about this with some say 1514 components are needed to be purchased, and raw material are 4000. So whole explanation with the block matrix here there. I'm not going into this each calculation. Now what I want to show here, that is the important expression for that Cobb-Douglas equation. This Cobb-Douglas production equation is that this is the concept of L. This L is nothing but the labor. So this is the skilled labor, and then L to the power gamma, how many labors and what the status of the labor you can assume, and that P is the that vector, that the activity vector, that means the skilled labor, how much activity they will do, that will be collaborated with the production system. So now if you are considering this labor capacity is very less, that means you are taking unskilled labor, so automatically production will be reduced. Similarly, if you consider semi-skilled, so little bit increase, and if you consider the skilled labor, so automatically increase. This is the major input that within the combination of the Cobb-Douglas equation, that means considering the labor within the smart production system. That is something big thing, whatever we have done there in the modeling. That is really hard to calculate the modeling part. And whenever we have to go through that system, we just take the Laplace transform, because there is nothing else which except that we can get the result. So that Laplace transform we take, and by taking the inverse Laplace transform we can get the labor input. That means each labor how much input is there. That means this is the amount of labor, that how many skilled labors we are taking, and using that inverse, first taking Laplace transform and then taking the inverse Laplace transform, we are getting the labor input, that each labor can contribute this amount of work. And this is the some calculation using that inverse transformation, and uh, some big size calculation is there, is in calculation of the recoverable inventory, disposal inventory. And then important task is here for um, one is that the in payment, that when it is entering and whenever it is going out, that both ways the transportation cost. So these are the something matrix representation using the same. NPV stands for your net present value for the transportation, and also the carbon emission cost. So this is the finally total cost, that going for first inspection, recycle, that NPV stands for net present value for first inspection for recycled item, then again second time inspection, then the setup cost, then the transportation, labor, remanufacturing items, and disposal. And this is the total expression. And now go for the numerical. So just this is the numerical data what we input for this one, and this is something activity result. So like total 50,000 products are manufactured, and please concentrate here that whatever be the products is produced, it is not the order quantity or not the production quantity. We just consider the in between products are produced, and the distribution is the two distribution center we are considering, only two packages system and three packages, like in a biscuit packet. So that in biscuit packet you can check that maybe 12 biscuits are there, maybe sometime four biscuits, sometime three. So we are considering just two types of that, not two types, means two products are there within a package, and there are three products within a package. So these two types of combination we considered, and near about 17,380 products out of these are collected from recycling. This is the biggest thing due to this smart production. And recycling time is, that is in terms of days, so that you can in short in twice in a week. So this you can go for recycling time. And whenever we are going for this NPV for each inspection, you please check that all costs are coming negative. What does it mean negative? That means everywhere we can try to reduce less, this amount, the original amount minus this one. And finally this amount is the profit, is means that this NPV is the ensures you have the this amount of profit for the using the smart production system. So that is the main contribution for this smart production till now, whatever we have done. And whatever the insight, we can say that the input output analysis give the industry manager a clear vision that total material flow on the system, not the finished products. That finished products means the you are considering the computer. That means we are, how many computer do you have? It's not like that. How many hard disks, how many RAM, how many keyboard, each information we need. Then the industry can decide whatever they how many computers they can sell to the market. So this will give you the clear vision of the all material flow, and this NPV gives a clear idea to industry manager for the time value of money within the desired time frame, because we consider that the inflation there. And of course the discounted sale is used there, that whichever that disposed, and rest part if it is not disposed and it cannot be used for again anything. So little bit discounted sales are there for something remanufactured products. Like suppose I'm just giving an example, the whole computer we when we are considering that totally gone, but maybe the keyboard is okay, maybe the mouse is okay, maybe the hard disk is okay, anyone if it is okay, so we can sell it in the discounted sale. It's not totally gone, some part spare parts maybe still ready for work. So this type of things we can consider for the discounted sale. So these are the references. Thank you very much. If you have any questions, so you can tell me.
हेलो गुड न्यून सर.
Good evening.
सर मैं ये आई एम आल्सो नो अंडरस्टैंड द cost of negatives means.
Sorry.
Sir, I am not understand your cost is negative meanings.
Not cost is negative. When you are trying to use the traditional production and the smart production, how much money it can save. So that's why every cost is showing the negative structure. You understand?
Okay, 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 sir. Okay.
Nice to see you, Dr. Mittal. Long time.
Nice to see you, Dr. Sarkar. A long time. Yeah, we can see it.
After Korea, I saw you anywhere.
Yes, yes, we met in
In,
Gurgaon, KOD, Kingdom
no,
of
no,
Dreams.
no, no, no. Yes, yes.
Yes,
We
yes.
visited. Yes,
You
yes.
came to Noida for some,
Yes, yes, yes. I remember. Now I got it.
yeah. So how is Anish and all?
Everyone fine, sir. Okay,
Mhm.
so any questions?
Any questions, please?